Section 1.3 Trigonometric functions. We do have 6 trigonometric functions. We have the sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and the cotangent theta. The theta is talking about the angle. You can use the degree or radian. Okay, we do have these 6 trigonometric functions. Reciprocal identities. For all angles theta for which both functions are defined, sine theta will be equal to 1 over cosecant theta, and cosecant theta will be equal to 1 over sine theta. So you guys need to remember that sine theta and cosecant theta, they are a pairs. Okay, that will be the reciprocal. Sine theta will be equal to reciprocal of cosecant, or cosecant theta will be equal to reciprocal of the sine theta. Also, cosine theta will be equal to 1 over secant, and secant will be equal to 1 over cosine. So these two guys are the pairs. Same idea with tangent and cotangent. So if you can find out what is your sine, then you just need to reciprocal of the sine, that will be equal to cosecant. Same idea. If you can find the cosine theta, if you want to find the secant theta, that will be reciprocal of cosine theta. Okay, reciprocal identities. White triangle. Base definitions of trigonometric function. Let A represent any acute angle in the standard position. So acute angle means less than 90 degrees. So we only consider the angle A here. The side BC opposite to the angle A, so we call this side opposite. And then the side next to the angle A, we call this is adjacent. And then the longest side in this triangle, which is opposite to the 90 degree, we call that a hypotenuse. Okay, if we want to find the side A, that will be equal to the opposite over hypotenuse. Okay, I need you guys remember that. When you're looking for the side angle A, that will be opposite over hypotenuse. Cosine A, that will be adjacent over hypotenuse. Tangent, that will be opposite over adjacent. If we want to find the cosecant A, that will be reciprocal of the sine A, which just means opposite over hypotenuse. If we want to find the secant A, that will be reciprocal of cosine A. So that will be hypotenuse over adjacent. Cotangent A, same idea, reciprocal of your tangent A. Okay, look at this example. Find the sine, cosine, tangent values for the angle A and B. Okay, first, let's try to find the A here, angle A. Sine A will be opposite over hypotenuse. So that will be 7 over 25. Cosine A, that will be adjacent over hypotenuse. So 24 over 25. And then tangent. Tangent A will be opposite over adjacent. So 7 over 24. Now, we try to find out the angle B. So when I consider the angle B, this time my opposite will become 24. Adjacent will be 7 and the hypotenuse will be 25. Okay? Sine B equal to opposite over hypotenuse. And then cosine B, that will be equal to adjacent 7 over hypotenuse, which is 25. Tangent B, that will be opposite over adjacent. Okay. If I put my white triangle into the rectangular coordinates in here, so I still have the angle A here, and then we do have a coordinate xy here. So the adjacent side of the A will be x. opposite side of the A will be y. And then the R here, that will be my hypotenuse. So side A equal to opposite over hypotenuse, which is gonna be y over r. And then cosine A, that will be adjacent over hypotenuse, which is gonna be x over r. And then tangent, opposite over adjacent, so y over x. Now we also want to find the cosecant. Cosecant will be reciprocal of sine, so that will be r over y. Secant, that will be reciprocal of cosine, so that will be r over x. And then last one, cotangent will be reciprocal of tangent, which is going to be x over y. Okay, one more time. If you guys can find sine, cosine, tangent, you should be able to find cosecant, secant, and cotangent. We're going to let point P, the xy, be a point other than the origin on the terminal side of an angle theta in the standard position. So you can see this is my initial size that will be on the positive x-axis. And then my terminal size, we're lying on here. That create the theta. And also we do have the white triangle. Okay, remember the Pythagorean theorem. When we have the white triangle, we could use the x squared plus y squared and then take the square root, that will be equal to r. Okay, so we do have the point xy and then we could find out the r here. And the 6 trigonometric functions of theta are divided as follows. Remember that if the theta, sine theta, you could pretend the theta is gonna be here. So sine theta will be equal to opposite over hypotenuse, which is gonna be y over r. Okay, and then theta, cosine theta, that will be equal to the adjacent over hypotenuse, which is gonna be x over r. And then we have the tangent. Tangent theta will be opposite over adjacent. So it's going to be y over x. And keep in mind that x cannot be equal to 0. When x equal to 0 here, tangent theta will be undefined. Okay, cosecant. Cosecant theta, that will be flipped about the sine theta here. So you could flip this guy, that will become r over y. Okay, one more time. Cosecant theta, that is equal to 1 over sine theta. So meaning that you could flip this guy, that will be equal to cosecant theta. And also y cannot be equal to 0, right? If r divided by 0, that will be undefined. And then another one, secant theta. Secant theta will be equal to 1 over cosine theta. 1 over cosine theta, you're gonna flip this guy. So that will be r over x. And then cotangent theta, cotangent theta will be equal to 1 over tangent theta. So you're gonna flip the y over x here. That will become x over y. I need you guys to remember these 6 trigonometric functions. If I give you guys the point xy, you should be able to find out the r, and also you should be able to find out the 6 trigonometric functions. Cogents. The x-axis and the y-axis divide the xy plane into 4 distinct regions called cogents. So you can see x-axis, y-axis. I create the 4 cogents here. And then we label the cogents using Roman numerals. So here, we call this as the cogent 1. And then we're going to go for the counterclockwise. Cogent 2, cogent 3, and cogent 4. Okay, 1, 2, 3, 4 here. For the cogent 1 here, the x-axis here will be positive, y-axis is also positive. So I could label like the coordinate. X and y is also positive. For the cogent 2, you could see the x-axis is going to be negative, right? But the y-axis is still positive. So I have a negative and positive here. Cogent 3, both of the axes is going to be negative. Cogent 4, x-axis will be positive, y-axis will be negative. Okay, right? Now, think about it. We could tell the sign of the x and y will be positive or negative, depends on the quadrant. How about the r? The r's formula would be x squared plus y squared and then square root. So r is always greater than or equal to 0. Another way to say r is always positive. Okay, right? I need you guys to remember the quadrant. Quadrant 1, 2, 3, 4, and also the sign here. Now, for the sine theta is equal to y over r. So think about it, r is always positive. The sign of the sine theta, it will be depends on your y. In the quadrant 1, if my sine theta is in quadrant 1, y is always positive. And when sine theta is in quadrant 2, the y is also positive. So we're gonna say, for the quadrant 1, quadrant 2, the sine theta is always positive. And then for the cosecant means 1 over sine. So they do have the same sign with the sine theta. Okay? So r is always positive and y will be positive in the quadrant 1 and quadrant 2. Okay, so you know sine theta and cosecant theta will be positive when they are lying on the quadrant 1 and quadrant 2. So if sine theta and cosecant theta, they are lying on quadrant 3 and 4, that will be negative because y in these two quadrants are negative. Now, look at the cosine theta. Cosine theta is always depends on your x, okay, because r is always positive. So when cosine theta in the quadrant 1, x is also positive. And then when cosine theta in the quadrant 2, the x is negative. So cosine theta in quadrant 2 will be negative. Okay, we're gonna look at it. Quadrant 4. When cosine theta in the quadrant 4, x will be positive. So we're gonna say cosine theta will be positive when it's on quadrant 1 and quadrant 4. So when these two quadrant is positive, cosine in the quadrant 2 and quadrant 3 will be negative. Okay, how about the secant theta? Secant theta means 1 over cosine. So same idea, if cosine is positive, secant theta is also positive in the quadrant 1 and the quadrant 4. Now we're gonna look at the tangent. Tangent theta is equal to y over x. Okay, so in the quadrant 1, positive over positive, we're still in positive. And then for the quadrant 3, when x is equal to negative, y is also equal to negative. Negative, negative, that will become positive. So tangent theta in the quadrant 1 and quadrant 3 will be positive here. Cotangent theta, that will be share the same sign with the tangent theta. Okay, right? I just explained to you guys the quadrants here, 1, 2, 3, 4, and then I give you guys the heads up which quadrant will be positive, which quadrant will be negative for the 6 trigonometric functions. On the session 1.4, we're going to talk about this part again. Example 1, finding function values of an angle. The terminal side of angle theta in standard position pass through the point x15. Find the values of the 6 trigonometric functions of theta. So we do have a point x and 15. And this coordinate will be located in the quadrant 1, right? Because both of them is going to be positive. So let's draw the picture. Okay, x and 15. And that creates a white triangle. And we do have the theta here. Okay, so based on this picture, we're gonna write it down the 6 trigonometric functions. So first, the coordinate of x equal to 8. So talking about this side, that will be equal to 8. And then 15, the y coordinate will be 15. So this side, y equal to 15. Now, we want to find out the r. Remember the formula, how to find the r? R will be equal to square root of x squared plus y squared. Okay, now we're gonna plug it in. use your calculator, you should get square root of 289. And r will be equal to 17. So I'm going to write it down here. Okay, right? When you have the points, try to sketch the picture here, get the right triangle. Figure out x, y, and the r. Now, we're going to find the values of the 6 trigonometric functions. First one, sine theta. Sine theta will be equal to opposite over hypotenuse. Okay, so we will have a y over r, which is going to be 15 over 17. Cosine theta, x over r. Adjacent over hypotenuse, so that will be x over 17. Tangent theta, y over x, okay? So opposite over adjacent, so that will be 15 over 8. Okay, secant. Secant, that will be reciprocal of cosine theta. So you're going to get 17 over 8. Cosecant, that will be the reciprocal of sine. So that will be 17 over 15. Last one, cotangent. Cotangent will be reciprocal of tangent theta, which is going to be 8 over 15. Example 2, finding function values of an angle. The terminal side of an angle theta in standard position pass through the point -3 and -4. Find the values of the 6 trigonometric functions of angle theta. The point -3 and -4. This point will be located in the quadrant 3, right? So we're going to draw from the standard position, that's of theta, until this point -3 and -4. It creates a white triangle here. So first, what is your x equal to? X will be equal to -3. And y will be equal to -4. Okay, now we're going to find out what is your r. Try to plug in this formula to find the r. You're going to get r equal to 5. Okay, so r equal to 5. And then we're going to find the values of 6 trigonometric functions. I want you guys try, find out the sine theta, cosine, tangent, secant, cosecant, and cotangent. Okay, sine theta is gonna be y over r. Okay, you should get -4 over 5. And then cosine theta, adjacent over hypotenuse, so -3 over 5. Tangent, y over x, you should get 4 over 3. Okay, negative, negative, you're gonna cancel out. Secant, that will be reciprocal of cosine, so that will be -5 over 3. Cosecant, that's a reciprocal of sine, right? So you should get 5 over -4. Cotangent, reciprocal of tangent, so that will be 3 over 4. Okay, example 3. Find the 6 trigonometric function values of an angle theta in the standard position if the terminal side of theta is defined by x plus 2y equal to 0 and x is greater than or equal to 0. Okay, instead of give you the point P, the coordinate, I'm going to give you the equation. And x plus 2y equal to 0, this is a straight line. Okay, so what we're gonna do, we could plug in any x here to find out what is the y, except the 0, 0. You never plug in x equal to 0 in this equation. And you could pick up any value. I'm gonna put x equal to 2. Okay, x equal to 2, then I'm gonna plug in this equation, find out what is your y. Okay, you subtract 2 for both sides, divided by 2 for both sides. You're gonna get y equal to -1. So you do have a coordinate, x equal to 2, y equal to -1. That would be similar to the previous example 1 and 2. You do have a coordinate, so you try to sketch on the rectangular coordinate axis. Once you have the coordinate, you try to draw the picture. Okay, so 2 and -1, that will be located in quadrant 4. Okay, 2 and -1. So the data is going to be from the standard position until here. Okay, now x is going to be equal to 2, y, that will be equal to -1. Now we want to find the r. R will be the hypotenuse in here. So plug into the formula, you're gonna get R equal to square root of 5. Okay, right? So we do have a 1 point and we find out R is equal to square root of 5. Now we try to find the values of the trigonometric functions. Side theta. Okay, so y over R. That will be -1 over square root of 5. You are not done yet because we do have a square root 5 on the denominator. We're gonna rationalize. Remember how to do that? You're gonna multiply by square root 5 over square root 5. Okay, so these two guys, square root 5 times square root 5, that will be equal to 5. On the top, that's a negative square root of 5. Okay, cosine theta, x over r. So you should get 2 over square root of 5. Again, rationalize. You should get the answer 2 square root 5 over 5. Okay, tangent. Y over x, you should get -1/2. Okay, cosecant. Cosecant, that will be reciprocal of sine, right? But we don't want to reciprocal for this guy. Because when we're reciprocal of these numbers, we're gonna get 5 over negative square root of 5. So we need to rationalize one more time. So we're gonna look at this one and find the reciprocal of this guy. So that will be negative square root of 5. Okay, secant, do the same thing. We're gonna reciprocal of this number. So that will be square root 5 over 2. Cotangent, reciprocal of this one, that will be -2. Okay, example 4. Find the values of 6 trigonometric functions for an angle of 90 degrees. So 90 degrees, we're gonna starting from here. It's 90 degrees. Okay, you could choose at any point on the y-axis here. So I gotta pick the easy one. X equal to 0, y equal to 1. You also can do x equal to 0, y equal to 2. You're gonna get the same answer. Okay? So I'm gonna choose 0 and 1. So x equal to 0, y equal to 1. Now we try to find the r. Plug it in, you should get r equal to 1. Now we're gonna find the 6 trigonometric functions. First, sine theta equal to y over r. So y, that will be equal to 1. R is also equal to 1. Okay, cosine theta, that will be x over r. x will be equal to 0 and r will be equal to 1. So that will be equal to 0. Okay, tangent y over x, so that will be 1 over 0. Remember that when 0 in the denominator, that will be undefined. Okay, secant. Again, secant will be reciprocal of cosine. So that will be 1 over 0, which is undefined again. Cosecant, reciprocal of sine, so it's still equal to 1. Cotangent, that will be reciprocal of this number. So that will be 0 over 1, which is going to be equal to 0. Okay, B. Find the values of the 6 trigonometric function for an angle theta in the standard position with terminal side full -3, 0. So -3, 0, that will be in here. Okay, so the theta will be equal to 180 because this is a straight line. Okay, write it down. X equal to -3, y equal to 0. Now, we're going to find out the R. That will be equal to 3. Okay, I want you guys try find out the 6 trigonometric functions. You have the x and y and r here already. Okay, check your work. Y over R. So that will be 0 over 3, which is going to be equal to 0. Cosine x over R. That will be equal to -1. Tangent 0 over -3. So this is 0 again. Okay, secant. Secant will be reciprocal of cosine, right? So that will be -1. Cosecant, reciprocal of this guy. So that will be 3 over 0, which is undefined. Cotangent. So reciprocal of this guy. So that will be -3 over 0, which is undefined again. Okay, so another way to say, when you know that the data is going to be 180, so sine 180, that will be equal to 0. Cosine 180, that will be equal to -1. Tangent 180, that will be equal to 0. Okay? Conditions for undefined function values. A quadrantal angle is an angle in standard position where the terminal side lies directly on one of the axes, x or y, meaning it falls exactly 0 degree, 90 degree, 180 degree, 270, and 360 degree on the unit circle. Identify the terminal side of a quadrantal angle. If the terminal side of the quadrantal angle lies along the y-axis, then the tangent and secant functions are undefined. Okay, you could look at the previous example. When your angle lies on the y-axis, tangent and secant functions are undefined. Y-axis. Okay, just like this example. Okay, y-axis. So tangent and secant will be undefined. When your angle lies on the x-axis, you will get undefined for cosecant and cotangent. Okay, if the terminal side of the quadrantal angles lies along the x-axis, then the cotangent and cosecant functions are undefined. So this is the example 3, and this is gonna be the example 4. Okay, you're gonna see the function values of quadrantal angles. Okay, 0 degree, 0 degree, and 180, 360, they are lying on the x-axis. And 90 and 270, they are lying on the y-axis. Okay, you could try it on your own. Try to graph it 270. Then you could take any coordinates with 270. You could do 0 and -1. Okay, and calculate the R. You should get those values. Okay. Using a calculator, function values of quadratic angles can be found with a calculator that has trigonometric function key. Make sure the calculator is set in the degree mode. Okay, when you guys using the TI-83 or TI-84 plus, you should click on the mode. The mode, you could find the radian or degree. Radian or degree. Okay, if you're working on the degree, make sure you choose the degree here. If you're working on the radian, make sure your calculator is in radian mode. One of the most common errors involving calculator in trigonometry occurs when the calculator is set for radian measure rather than degree measure. Be sure you know how to set your calculator in degree mode. Okay, even like the regular calculator, you should see just like this calculator, you're gonna see the degree here. So I could change it degree or radian. Okay, make sure you know how to do it on your own calculator. That's it.